Hello to everybody who chose the video option. So today we are talking about conditional probability, and we're going to be going over two rules. There is the rule of conditional probability, which is here, and I would recommend that you pause and write this down. There's also the multiplication rule, which is here. And I would also like you to write this down, just the parts of the equation. And then as we go on, you can take notes about what that equation means. So we're going to take a look at this website here about conditional probability. So we have basically two types of events. We have independent events and we have dependent events. Independent, just like it sounds, means it's not affected by other things. So the classic example is a coin toss, right? If I toss a coin and it lands on heads, that doesn't mean that the next time it has to land on heads again. And it also doesn't mean that it's going to land on tails, right? One coin flip doesn't affect the next coin flip. So, I don't have a coin, I have a coaster. But if I flip it, whatever answer I get, heads or tails, is going to be completely independent. It never changes based on what happened previously. We're looking today at dependent events. Now, a dependent event is different because what happens the first time is going to impact what can happen the next time. So, for example, if you have a bag full of marbles, 2 are blue and 3 are red, and you pick one at random, well, you know that the chance of getting a blue marble is 2 out of 5, 2 divided by 5. But then if you want to know what's the chance of getting a blue marble the second time, that's going to change based on whether you got a blue marble the first time. So just like we're seeing in this diagram, if you pick a blue marble the first time, then there's only one blue marble left and 3 red marbles. So it would be 1 divided by 4 is the chance of getting a blue marble that second time. If you picked a red marble the first time, then you still have 2 blue marbles and you only have 2 red marbles. So the chances is 2 divided by 4. So this is an example of a dependent event because you're going to get a different probability for the second one based on what you got for the first one. Now we're going to go over some equations that we can use to explain these things. But first we'll take a look at tree diagrams. And tree diagrams are helpful to some people. I will be honest, I find them a little bit confusing, but I think for some people they help you kind of visualize the options, right? So for this example, you're starting with a bag full of 5 marbles. You pick a blue marble. Well, there are 2 blue marbles out of 5 marbles total, so that's a 2/5 chance. Or if you pick a red marble, there's 3 red marbles out of 5 marbles total, that's a 3/5 chance. So you draw the first branches of your tree. And then for each time that you're picking another marble out of the bag without putting any back in, you just draw another branch of the tree. So if I picked a blue marble the first time, this is what's left in my bag, 1 blue and 3 red. And so the next time there's a 1 out of 4 chance of getting a blue and a 3 out of 4 chance of getting a red. And for the option where I picked a red the first time, then I have 2 blue and 2 red left. So for the second draw, there's a 2 out of 4 chance of getting a blue marble and a 2 out of 4 chance of getting a red marble. So that can help you see the changes in the events. So for this example, there's event 1, which is picking the first marble, and then event 2, which is picking the second marble. And the second event is dependent on what happened the first time because the probabilities change depending on which marble color you picked at first. So here's where we're going to come to notation. That's just a way of saying, how do we write this mathematically? So we already know that PA is probability of event A, right? So if event A is picking a blue marble, then the probability of A is 2 out of 5 or 2/5. And event B, like we saw in the tree, if you picked a blue marble the first time, then the chance is 1 out of 4. That is probability of event B. So probability of picking a blue marble second, given that you picked a blue marble first. So when you see this PB with a line A, it's probability of event B given that event A happened. So if we scroll back up here, here's what we're looking at. We're looking at what's the probability of picking this blue marble the second time, given that we got a blue marble the first time. And so judging by this tree, the answer was 1/4. This example is looking at the probability of getting a blue 2 times, and that is where we would multiply the two probabilities together. So that's the probability of B and A. So 2/5 times 1/4, two separate things. But for this one, the probability of event B given event A, like we see here, is 1/4. I would like you to copy down this part so that you have a clear explanation of what these mean. So the probability of both A and B happening equals the probability of A, that first one, times the probability of B given A. Now let's look at another example, and we're going to use this equation to help us understand it. So drawing 2 kings from a deck. We have a deck of cards, and a deck of cards has 52 different cards, right? And we want to know what are the odds of drawing a king. But we don't just want to know the odds of drawing a king. We want to know the odds of drawing a king first and second. So the first time I have 52 cards, and out of my 52 cards, I have 4 kings. I'm going to make myself bigger so you guys can see me. Hello. Okay, so I have 4 kings, right? And so the odds the first time are going to be 4 divided by the total of 52. That's the odds of picking a king the first time. And so I'm going to use that as my PA. So let's say the first time at random, I draw the king of hearts. And I'm not going to put it back. I'm going to take the king of hearts and get rid of it. So now I only have 3 kings left. So when I calculate my second probability, the probability of picking a king, given that I got a king the first time, it's going to be 3, but not 3 divided by 52 because I threw this guy out. He's gone. So now it's 3 divided by 51. Those are my 2 probabilities. And you can see this on this screen, right? Let me move this. Here we have 4 over 52 and then 3 over 51. So if I want to know the probability of picking one king and then a second king, I'm going to multiply those 2 numbers together. So I have 4 over 52 times 3 over 51. And when I multiply that together, it's going to give me a fraction, or if I want to convert it into a decimal, I'm just going to divide 1 divided by 221, and I get 0.0045, which if they make that into a percentage, is going to be 0.5%. So there's a very, very low chance of picking a king twice, right? Here is another important formula for us. So take a moment and copy down this formula and the sentence explaining what it means. So this is just an adaptation of the first formula that we saw. This is how we can calculate if we don't know what's the probability of picking that second king given that I got the first king. So the probability of event B given A equals the probability of A and B divided by the probability of A. We can actually check that this works, right? We can do it using the probabilities that we saw above. I'm going to scroll up a little bit so we can see both. This does go backwards because if I want to know the probability of picking a second king given that I picked a king the first time, well, I'm going to do probability of A and B. So that's 1 divided by 221. We calculated that one. And then I'm going to say divided by probability of A, which we said was 4 divided by 52. And if you put this into your calculator, 1 divided by 221 divided by 4 divided by 52, it gives me, and I'll write this out for you, 0.0588. Well, that is the same as if I say 3 divided by 51. So you can check that for yourself. It's just walking backwards to get a different number if we don't know some of the other numbers. So let's look at an example of this one. So if we know that 70% of your friends like chocolate and 30% like chocolate and strawberry, okay, that 70% who like chocolate, that's the probability of A, just the one thing. And 35 who like chocolate and strawberry, that's the probability of A and B. Chocolate is A, strawberry is B. So I'm going to do 35% divided by 70%. Now remember that that is going to be either 35 divided by 70 or like they did here, 0.35 divided by 0.7. Either way, when you divide it, you get 0.5, and 0.5 can be written as 50%. So that means that my probability of liking strawberry, given that you like chocolate, is 50% or 0.5. So remember that every time that we read this, it goes in one direction. This is the probability that somebody who we know likes chocolate also likes strawberry. It doesn't go the other way around. So order is important. Let's look at one more example. Okay, this is a soccer game. So this is about the coach Sam. And with Coach Sam, the probability of being a goalkeeper is 0.5. With Coach Alex, the probability of being a goalkeeper is 0.3. Anybody who's on a sports team probably knows, if you have a good relationship with your coach, maybe they're more likely to play you. Or maybe they have a different strategy that they're using, and so they're going to be more likely to use certain plays. So you're actually going to be playing differently based on who your coach is. So about 6 out of 10 games. What is the probability that you'll be a goalkeeper today? So they actually said that the probability is 0.6 instead of 0.5. So we're going to use that 0.6. So today, if Sam shows up as the coach, then it's a 0.6 chance that you will be goalkeeper. If Alex shows up as coach, it's a 0.4 chance that you'll be goalkeeper. That's one, right? But, oh no, that's what they're saying, is the probability that they'll show up. So the probability that Sam will show up is 0.6, the probability that Alex will show up is 0.4. And if Sam shows up, so given that Sam shows up, what's the probability that you're going to play? Well, that's 0.5. So the probability that you'll play is 0.5 for Sam. 50% yes, 50% no. Then for Alex, it's a 0.3% chance that you'll play. So we're going to make this 0.3 yes, 0.7 no, right? These are all of the options, right? But we don't want 4 options, we want 2 options. What's the probability that you will play and what's the probability that you won't play? So they're actually going to add up these two options, right? Because we have 0.03 and 0.12. How did we get 0.03 and 0.12? Well, we multiplied 0.6 times 0.5, and that gave me the 0.3. And then when I wanted to find this other one, probability of Alex being the coach and you playing is 0.4 times 0.3. So that is 0.12. And if we want to know the probability of you playing at all, we're going to add up 0.3 plus 0.2, and that gives me a 42% chance that you're going to be a goalkeeper today. Now this probability here, that if we want to write it, is going to be probability of playing goalie, right? Total. So which of these numbers here is the probability that you will be goalie given that Alex is the coach? Well, this is where we need to look at what we have here. So we see that Alex is the coach. And when Alex is the coach, you have a 0.3% chance of being goalie. So this 0.3, that is the probability of playing goalie given, which I don't have a good symbol for that, but I'm gonna, oh, there we go, given Alex is the coach. There we go. So if we wanted to know, based on what we had up above, if we wanted to know there we go, either one of these, probability of A and B, what's the probability that you play goalie and Alex is the coach? That's when we multiply together. This one is a 0.3. All right. So that is as far as I'm going to go today. You can continue to look at these examples to give you more practice with how we can draw these trees and how we can find these answers. And then go ahead and do the practice problems that are on Schoology.